Typical probability questions again are about probability identity. They tell us there is two event A and B, and then complementary event of A is A prime. So they give us some information. They give us some tips that we are going to consider this item, or otherwise we are going to find PA. So you may take PA equal to P. It's much easier for you to understand if you use a single letter to represent the whole thing. Otherwise, it's difficult for you to read the equations. But anyway, it's just up to you. We have this item equal to 0.12, and also we have this one, the conditional probability. It's much easier to use this one. We just use the first item and the second item divided by the given condition. We get 2 times of PA. So this is A, and then what below the fraction line is 1 minus A. And then now there is a problem is we need to handle this. So we use this information and see whether we can work out this one. By the identity, we consider not A and B together with the hints not A and not B. It gives all the possibility to create A prime. So this is the total possibility of not A here. Not A can be expressed by 1 minus A. Oh, change it to A. And then this part is given 0.12, and this is the item we want to express. So the only part missing is 0.88 minus A. Then we can put it back here. We have 0.88 minus A over 1 minus A equal to 2A. We successfully transfer all the items to in terms of A only. And we realize that this is a quadratic equation, so we use the quadratic strategy. Then we just use calculator. A equal to 1.1 or A is equal to 0.4. But of course, this is impossible to have probability larger than 1. So PA is equal to 0.4. If A and B are independent, this is the given condition. We are going to find PB. This is just simply so stupid. We have this equation already. Which means that this item is equal to 0.8 because we know PA already. After that, is because A and B are independent. That means existence of A totally do not affect the existence of B. So by using this logic, we know that the condition is totally meaningless. It do not affect the total probability here. So it's 0.8, which means that PB itself is 1 minus 0.8. We get 0.2. You may get it directly, like this. But this based on you really understand what is the meaning of independence. If you do not notice that, fine, maybe you can start working from this one. We get this one equal to 0.12 and see whether we can get a PB. Something which is related to this is P not A and B together with P A and B. The first case and the second case to get B, then we have PB, the total probability identity. Then the first term is 0.12, which is known. The problem is the second term. It's because they're independent, so this is just simply equal to PA first times PB is equal to PB. Then this is a linear equation. We can just group all PB to one side. 0.6 times PB is equal to 0.12. So both sides divide by 0.6. We get 0.2. But it's just simply so stupid. We can get it from very beginning like this if you understand the meaning of independence. But sometimes if you do not use it usually, then maybe there is some logical mistake you don't realize. So using a different method to double check is good.